So this is a video with a review of some derivatives. This is review number 1. There were a few that are more covered in a Calc 2 framing, so I'm going to do those with you. I'm going to get you started on some of the more difficult ones and some of the ones that some people had questions about. So I would like to start with F. So F says, given that y equals this equation, determine the value of dy dx when x equals -1. Okay, so we're really going to focus on this in two parts because there's two terms. The first term requires that we use the quotient rule. So we're going to do the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Now that's just for that fractional piece there. Now we've got to move more to this -10x piece, which the derivative is just -10. Now the instructions say to find the value of dy dx, which is our y prime, when x equals -1. So then your job will be, you need to plug in -1. So that's F. The next question I had about was P. Well, P is more of a Calc 2 problem, at least at YSU. So let me just give you the derivative. So the rules of derivatives of e's are kind of neat. They're actually e to that function of x times the derivative of that function of x. So the answer for the derivative is 4 times e to the 4x. And if you take Calc 2, they'll describe that more. The only job left is plug in 0. Okay. The next question people had was about S. It says determine the slope of the tangents to the parabola at its points of intersection with the x-axis. Now we only want the positive slope because it's in the Sudoku. We only use positive numbers, 1 through 9. So first, let's think about where does this equals 0. That's where it hits the x-axis. It's our x-intercept. I'm going to multiply through by -1 because it's an equation. I'm allowed to do that. I'm going to factor. I'm going to solve. So the x values I'm concerned about are when x equals 2 and when x equals 3. So we want to know where the slope of the tangent, or what is the slope of the tangent at those x values. Well, what's the slope of the tangent? Well, the slope of the tangent, you might recall, is just y prime. So y prime is -2x plus 5. If I could write that out right. And so all we're going to do is we're going to plug in 2 and we're going to plug in 3. One of them will give us a positive value and one of them will give us a negative value. We want the one that gives us the positive because that's what we use in Sudoku. Okay, so there's letter S. Let's take a look at U. U is also a Calc 2 sort of objective. These are parametric equations. They're really good describing motion, especially if your motion is in something that is not a function. And so what you do is you have a parameter, in this case t, and you define, well, what is the x doing and what is the y doing. So the cool part is dy dx is just going to be the derivative of y in terms of t divided by the derivative of x in terms of t. So let's do that. So if we look at our y here, what's y prime in terms of t? Well, dy dt is just going to be 3 times 8/3, which is 8, and then the third becomes a squared, and then we go -8. And then we're going to take our x and find x prime in terms of t, which is 2t plus 2. And then all we got to do is we're going to let t equal 3. You plug in 3, you got u. Okay? So there's u. The next one, which is also a Calc 2 sort of, in most Calc 2s, are natural logs. So let's talk about y. The interesting part about a natural log. So I think we should probably write this, the natural log of x plus 3 squared. It's not written real nicely, but the rule is the derivative of a natural log of some function of x is 1 over that thing times the derivative of that thing. Well, that is a perfect chain rule. So we're going to do the chain rule here. So we're going to drop down the 2. The x plus 3 becomes a 1. And then we're going to multiply by the derivative of the inside. Well, the derivative of the inside of this is 1. So we can write it or not. It's not going to hurt anything. And when you simplify that down, we get 2 over x plus 3. Now, they wanted you to find it when x equals negative 2. So you plug x equals negative 2 into that. And there you go. There's v. Next one I want to talk about is w. So somebody had a question about w. This is a chain rule. I'm going to set it up for you. This I would consider my first. This, let's consider the second. Okay, so how does the chain rule work? What's going to be the first, which I'll keep in kind of this orangey red color, times the derivative of the second. Now, how do we do the derivative of that? Well, we're going to drop the 2, write the 3x plus 4 to the first, times the derivative of the inside. And then for the product rule, it's going to be an addition. And then it's going to be, okay, so it's going to be the first times the derivative of the second plus the second, 3x plus 4 squared, times the derivative of the first. Now the first is that, include that 1/18th, so it's be 1/18th times, that does say 1/18th. Let me make it look nicer. Times the 3 that drops down, times 2x minus 1 to the second. Here, I'm sorry. Let me make this a little nicer. Okay. So it's going to be 3x plus 4 squared. And then 1/18th, 3, 2x minus 1 squared times the derivative of the inside, or 2. Okay. Now what do you have to do? Well, you still have to plug in 0 for all of the x's, and then you got it. Okay. Let's take a look at x. So we need to find DYDX. So if you can, it's always a good idea to isolate the y. And we can pretty easily here. I think we want to get and write that as x to the negative 1. And then we just use our rules, drop down the negative. It will become a negative 2. Now here's the thing. We are plugging in, this is our x value. So that's what you're plugging into that, okay? So let's go. So we've got y prime would be positive 4x to the negative 2, okay? And so that's really 4 over x squared. And so when we plug in negative squared to 2 squared, we get 4. 4 divided by 4 is 1. Okay. So there's that one. And I think y is the, y is the last one we're going to do. And so y prime, this is going to require the chain rule. Just leave that 448 over 5 out in front. We multiply by 5, leave it alone, make it a 4, but then we must do the derivative of the inside. Now when we do the derivative of the inside, it requires the chain rule. So it's going to be bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. And then they see this little, it's hard to see here, but this says, that implies I want to find the derivative of y in terms of x when x equals 1. So now wherever we see the x's, put in a 1, and you got it. So there are some hints for review number 1 about derivatives. I hope that